For my Math 2 students, this is video 3 in our series on operations with polynomials and evaluating functions. And in this video, I'm going to show you how to multiply polynomials. The first example happens to be a monomial times a trinomial. And in order to multiply this, I'm going to have to distribute this monomial and multiply it times each of the terms inside the parentheses. So I'm going to take 4y and multiply it times 6, which gives me 24y. I'm going to take 4y and multiply it by negative 2y, which gives me negative 8y squared. And 4y times 5y squared is positive 20y to the third. So now what I know is I have my answer, but it's not in standard form. So I'm going to reorder the terms in the highest exponential order to the lowest, 20y to the third, minus 8y squared, plus 24y. And I would state my answer to this multiplication problem just like that. Notice in the second problem, I'm multiplying a binomial times a binomial. And it's so tempting to want to just multiply the first two terms and the last two terms and get something like 12x squared minus 5. But we can't do that because the distributive property says I have to multiply this first term times both of the terms inside the parentheses. And I have to also do the same procedure with the last term in the parentheses. So let's go ahead and do that. Some of you use a FOIL method to multiply two binomials, others use the box, and either method is just fine. For this example, I'm going to FOIL. So I'm going to multiply the two first terms and get 12x squared. Then I'm going to multiply the two outer terms. That's where we get the O in the acronym FOIL. So 6x times 1 is 6x. Now I've done my first and outer. Now I'm going to multiply my inner two terms, negative 5 times 2x, which gives me negative 10x. And then I'm going to multiply my last two terms, negative 5 times 1, and that gives me negative 5. So what I notice when I do a FOIL is I notice the two middle terms are almost always like terms. Notice like terms have the same variable taken to the same power. So I need to add these two terms. And when I do, it gives me 12x squared minus 4x minus 5. And this is how I would write my answer. For the third example, I'm going to multiply these two binomials using the box method, which is pretty much the same thing as FOILing. It's just kind of a geometric representation. So when I use the box method, and I think I need a little more space than I've got right here, so let me put it out to the side of the problem. When I use the box method, I write my first binomial on the top and my second binomial along the side. And notice I'm multiplying, it's kind of an area type concept, length times width in a certain way. But I'm multiplying what's here by what's here to get 6x squared. I'm also going to do that for this box. I'm going to multiply length times width, which is negative 1 times 3x, or negative 3x. 2x times 5 gives me 10x, and negative 1 times 5 gives me negative 5. Now again, when I do this, I'm going to notice that my terms on the diagonal are almost always like terms. So I need to combine those in my final answer. And I get 6x squared. Negative 3x plus 10x is 7x. And then minus 5. So here's how I would write my answer. You are welcome to multiply binomials either by FOILing or by using the box, whichever suits you best. So let's go ahead and do example number 4. In example number 4, something interesting happens. Here's my first two terms, and notice I have 3t squared times t squared. And what is it that we do when we multiply? We do what to the exponents? We add them. So my first two terms become 3t to the 4th power. Let me scoot this up a little bit so you can see it better. 3t to the 4th power. So the product of my first two terms is 3t to the 4th. Now I need to do my outer two terms, which is 15t squared. My inner two terms, minus 8t squared, and my last term gives me negative 40. And again, my middle two terms are like terms, so let's add those to get 3t to the 4th. 15 minus 8 is 7. And that's going to be a positive 7t squared minus 40. So there I have multiplied two binomials. I'm going to leave you to try number 5, and I'm going to hop down to number 6 real quick. Take a look at number 6. This is 2x minus 3 squared. Again, many students jump to the conclusion that that means you should square 2x and square 3 and get 4x squared minus 9. But you can't do that. That's a big mistake lots of algebra students make. This expression actually means 2x minus 3 times 2x minus 3. And when you go ahead and take the time to write it out like that, you realize that you need to either use the box method or the FOIL method to multiply these together. So let's go ahead and do the box again, just for practice. And I get 4x squared minus 6x and plus 9. I'm multiplying what's on the side of the box times what's at the top of the box. So 2x times negative 3 is negative 6. Negative 3 times negative 3 is positive 9, and so forth. Again, I've got like terms on my diagonal, so this becomes 4x squared minus 12x plus 9. I happen to kind of like the box method best, but again, either one will work. You finish the rest of the worksheet and make sure and check your answers.